So this question here, we are going to use a compass and a straight edge to construct a line tangent to circle O at point A, and it tells you that OA is a radius. Well, a tangent line that's drawn to a radius is perpendicular, so really we're doing the construction for perpendicular lines, which is something that you guys have done before. Very first step, take your straight edge and you want to extend OA, just go out, doesn't matter if it's too far, just extend it out. Okay, the next step is we're going to take the compass, and since the tangent line has to go, it's going through point A, we want to place the end of the compass so the clear piece goes on point A. Now open it up as much as you want to. You don't want to go past O though, so like about here is good. Okay, so clear piece on A, the hole where the pen or pencil is going to go, just like open it up a little bit, and you want to just draw a circle. Your circle might be a little bigger than mine, might be a little bit smaller. Basically, we just need that circle to intersect the arc. The circle to intersect that line in two places. So if you make it too big, it's going to go past O and it won't cross it twice. So it has to cross that line we extended twice. All right, the next step is you are going to put the clear piece on one end where the line and the circle intersect, so I did it on the right side first. I'm going to open it up so that the other end of the compass, where your pen or pencil goes, is at the end of the circle. So it's like the two places where the circle intersects the line, those are the two places where your compass is going to go, the clear piece and then the hole. And you can go either above or below when you draw this arc. I'm going to go below. So I'm just going to go below and I'm going to draw an arc. That's good enough, because when we get to the next one, we're going to do it again, and then it just has to intersect that arc. So I'm just going to flip the compass around, just kind of adjust here. And we're going to do the same thing. Don't change the compass setting. So when I place it now, it's the two places where the circle intersects that line. So I have the clear piece on the left side where the circle touches the line, and then I have the hole on the right side, and I'm going to go below again. So if you went above, just do the same thing. Go below, and this is what you guys want. You want a place where, let me kind of draw it in for you. You want the point of intersection where those two arcs, right there, where those two arcs cross. And we're almost done. We just have to draw on the tangent line. So the tangent line is going to go through point A. It's going to touch the circle at point A, and it's going to go through that red point that I made below where the two arcs intersect. So take your straight edge, and it should have arrows on it. So let me just get that. Ooh, I don't know if this is going to make it at both. Is it? Nope, it's not. Okay, hold on. Got to pause it. Okay, I'll just make the arrows myself. Anyway, so now we're just going to draw a line that goes through the point where the two arcs intersect and through that point A, and you just want to extend it out longer. And because it does say construct a line tangent, I'm just going to put arrows at the end. So there's your tangent line, and you can tell that it's perpendicular to the radius, forming a right angle. So let's focus on some problems that use Theorem 5 that states that if you have a line that's tangent to a circle, meaning it touches at one point, it's also going to be perpendicular to the radius. So number 2, we have triangle AP is tangent to circle O at point A. OB is 7, BP is 18. So part A, we're going to find the length of AP. I'm just going to call it X. Well, you guys can see that we have a triangle here. It's a special kind of triangle because using the theorem, the tangent line, AP, you can see is drawn to the radius. So we can put in that we have a right triangle. And right now it might look like we don't have enough information, but if you look at the radius OB, it's 7, and OA is also a radius within the same circle, so that has to be 7. Since we're just dealing with the sides of a triangle, we're going to be using Pythagorean Theorem to find the length of AP. The C is the hypotenuse, which is the side across from the right triangle, or the right angle, I mean, and you'd have to add the 7 and the 18 together, so that full length is 25. The other two sides of the triangle, one of them is X and one of them is 7. So we're just going to square everything. So we have 49 and we have 625. Subtract the 49 from both sides and you get x squared equals 576. Then we're going to take the square root and when you put it in the calculator, you get 24. I'm just going to put that into the right triangle because there's different ways to do part B and some of you might want to use that side. Part B says, what is the degree measure of angle P to the nearest degree? Well, we still have a right triangle, but now we're dealing with an angle, and this is going to be a trig problem, sine, cosine, or tangent. All three sides are now labeled because we did find that AP is 24, so really it doesn't matter if you use sine, cosine, or tangent. I would just pick whichever one you want to use. Maybe you don't want to use that 24 from part A. Well, if that's the case, the side across from your angle, angle P, is the opposite side. And across from the right angle is the hypotenuse. So if you want to do opposite hypotenuse, that would be sine. So the sine of theta equals opposite over hypotenuse. Okay. So theta is the angle. Well, we don't know what that is, but it is angle P, so I'll just change to that. The opposite side's the 7, and the hypotenuse is the 25, because you have to add the 7 and the 18. And when you don't know the angle in the calculator, you have to press second sine. You have to do the inverse. So you would type in second sine, you put in 7 divided by 25, and get, to the nearest degree, you would get 16 degrees. So let's just do another problem, kind of different, but still using that theorem. So number 3, we have AC and BC are tangent to circle O. So the second it says it's tangent to the circle, you can put in those right angles right away because you're going to use them at some point. It says that the measure of angle ACB is 38 degrees. What is the measure of angle AOB? Well, we have a quadrilateral right here. We have 4 sides, 1, 2, 3, 4. And the angles in a not a triangle, the angles in a quadrilateral add up to 360. Right? So if we can figure out what all those angles add up to, we can just add them and subtract from 360. Well, we know that A and B are both 90, and then the third angle there is 38 degrees. So when you add up 90 plus 90 plus 38, you get 218. And when you subtract that, you get 142. So angle AOB is 142 degrees. And theorem 8 says that if opposite angles in an inscribed quadrilateral are supplementary. So an inscribed quadrilateral, 4-sided figure, the angles are all inscribed, which means if you look at number 6, that each of the vertices are on the circle. And the theorem tells us that the opposite angles are supplementary, meaning they add to 180. So if you want to make a little note, when you add the angles across from each other, they will add to 180. Okay. Number 6, so if we have to find angles x and y and then explain, well, angle x is opposite from the 115. So you would just do 180 minus 115, and you would get angle x to be 65 degrees. Angle y is opposite the 30. So again, just do 180 minus 30, and you get angle y to be 150. And to explain, you're really just stating the theorem. Opposite angles in an inscribed quadrilateral I'm just going to write quad are supplementary. And if you go to do a problem like number 7, same kind of thing, it's just this time it's algebraic. So opposite angles here, we want to find x. Well, we know that opposite angles are supplementary, so when we add those two expressions, it's going to equal 180 degrees. Combine like terms, so if I combine the x's, I'm going to have 59x. Negative 2 plus 5 is 3. Then we're going to subtract 3 from both sides, and we would get 59x equals 177. Divide by 59, and then the value of x is 3. Nice circle.